Hey everyone, my name is Timo, and for my fellowship project, I built a tool for automatic information extraction from medical documents. For the last 6 weeks, I've been working with IQVIA, and IQVIA is a global consultancy specializing in healthcare and life sciences, and they use technology like AI and data science to create business value for their clients. So the healthcare industry is quite special because it's very heavily regulated. And that means just naturally, there's a lot of technical documents being published every day. This could be laws, treatment guidelines, or intellectual property. And the amount of documents that is published every day is quite unmanageable if you don't have any tools to help you. Usually, employees in the industry have to read through these documents manually, which is inefficient and frustrating. And even if you try, it is more or less impossible to stay well informed. The solution we propose is to use AI to build a reading tool which helps employees in the industry to extract information which is actually relevant for them. What is the tech behind it? So state-of-the-art natural language models usually use the encoder-decoder architecture, and I'll just quickly explain how that works. So imagine you have a large input text, then the first bit of the model, called the encoder, will take that text and convert it into a mathematical representation, which contains most of the information of the original text. But now we just have a list of numbers, so to say. The second part, the decoder, will take this information and create something new, for example, a rephrase text. In our example, an input could be a rather lengthy paragraph about a clinical trial, and the output is a summary, which is just a shorter text containing the most important bits of the input. How does that look like in practice? Well, these language models are very large and very complex and expensive to train. So usually you don't design these models yourself, but you use the ones which were designed and trained by the big tech companies which publish them. And what you have to do is that you have to assess their performance on your specific task, which in our case are how well do these models understand medical documents. And for that, we had a data set of medical documents with a gold standard summary, which was created by domain experts. And we compare this summary to the machine created summary. For that, we have a score, and the higher the score, the better the model performs. We see that these state-of-the-art models, BERT, BART, Pegasus, with increasing complexity, they create better and better summaries, and the champion model BART has a score on medical documents which is comparable to what has been reported on normal text. So we have a model which we can use, but we have one problem, and that is that these models can only read in one paragraph or a couple of hundred words at a time. So if we actually want to read through pages of documents or even a whole library of documents, we need a way for paragraph preselection. And that we can achieve, again, using an encoder model. So if we have a large PDF, the first step we do is we chop it up into smaller paragraphs, which then can be read by the encoder and again converted into the mathematical space. We can think of it as just being numbers or coordinates in space. Now we can apply the same algorithm to a query or a question we are interested in, like what is the cost of treatment? And doing so, this retriever model can identify the closest paragraphs to the question we have and thus get us the content which is actually important. Now, I think it is obvious that creating a tool which is actually useful requires the chaining of models or building a pipeline. The first model would be the encoder splitting up the documents into smaller parts and converting the text to a vector. Then the retriever identifies the paragraphs which are similar to the query. We have a Q&A model which extracts the top answers, and finally a summarizer to give us the final output. That was a lot of models and a lot of tech, but how do we apply that if we want it to be useful for non-tech savvy employees? For that, I built a front-end application which can be used by everyone who knows how to use a computer. So it's just your mouse and keyboard. You can add files you are interested in, and then you can ask questions or formulate queries like, what are the adverse drug effects? And the tool will give you an answer. Here we see the most frequent serious adverse events are, so we get a comprehensive summary about the information present in the text. So what is the impact? Now we have a user-friendly application which can be used by people who don't have tech knowledge. And instead of manually reading through a lot of documents, this is of course very time efficient. So we save a lot of working hours. And for IQVIA, it is, as a consultancy, very important to also think about how to sell their stuff or how to communicate to clients. So they have a prototype they can show and pitch to clients who are interested in that new capability and secure follow-up contracts. Thanks for your attention.